Hi and Assalamualaikum. So this is the video presentation of our hydrology project, Group D2. First, let me introduce our group members. The first one is Muhammad Imran Shakir bin Hussin, AA201091. Second is Muhammad Emir Syamin bin Muhammad RIZAL, AA200014. Third, Muhammad RIFZAL bin ROSLAN, AA200480. And lastly, Nur SYAMIMIE binti AZHAR, AA200822. For introduction, flooding is the most common weather-related hazard on the planet. It can happen almost everywhere. A flood is defined as overflowing water into normally dry land. Flooding is frequently associated with heavy rainfall, but floods can occur in a variety of ways that are not directly related to ongoing weather events. As a result, a comprehensive description of flooding must include processes that may have little or no relationship to meteorological events. Nonetheless, it is clear that, in some ultimate sense, the water involved in flooding fell as precipitation at some point, possibly a long time ago. No matter what specific event caused the flooding, the origin of flooding ultimately lies in the atmospheric process that produces precipitation. Flood causes damage to the immense power of moving water and the disposition of dirt and debris when floodwater recedes. People who have never experienced a flood may have a naive understanding of the dangers of moving water. The energy associated with moving water grows as the square of its speeds. When the speeds double, flooding is usually associated with water moving faster than usual, due in part to the wake of an increased amount of water upstream, which cause an increase in the pressure gradient that drives the flow. In most cases, the debris carried by the flood waters magnifies the damage potential of the flood. For this project, we choose a self-closing flood barriers SCFB construct entirely of aluminium metal. It is a comprehensive design with a product-specific solution to handle extreme flooding and water incident situations. The SCFB provides the best protection against extremely high water levels. For the background study, in Malaysia, Kuala Lumpur was built along the floodplains of the Klang River and has thus been subjected to flooding since its inception. Flooding problems in the Kuala Lumpur city centre have become more frequent and severe as a result of rapid development. Construction and blockage at various bridge crossings, particularly at the Tun Perak Bridge, Gombak. This factor contributes in some way to slowing the flow of the river channel and as a result increasing floods in the city centre.
Today I'm going to present about issue of our project. The northeast and southeast winds will influence the climate. The former which dominate between November and February comes a lot of rain over Peninsula Malaysia, East Coast, Sabah and Sarawak. The southern monsoon provide rainy winds for April to December. But rainfall is typically less than during the Indonesian monsoon. This is typical of our Malaysian of rain activity. Flood appear to be becoming more common in recent years, particularly in major cities. The main cause of flooding in Malaysia is higher runoff rates. Is what rates caused by urbanization. The occasion is a high metropolis with a large number of towering skyscrapers that is considerably more sophisticated. Because of the location proximity to a river, the river gravity is insufficient, resulting in flood with the river gravity is increased. That's it for the issue. I'm going to talk about the construction process. First, I'm going to talk about the process. First, on-site survey will be necessary for both plotting purpose as well as modification and installation specifics. An initial layout design will be created to show the location and approximately dimension of purpose. After the water has stopped flowing, the drainage and surface speed will attend. This is determined by the relative water level and ground level. It comes in 1 meter length and may be combined. The equipped with pillar may shift direction or the wheel involve straight line. In this section, you can see the concrete basing barrier. As a result, the part of the barrier must be incorporated and divided into pieces of 500 meters. A barrier protects a building entrance and driveway. And lastly, the data level sand gradient and crucial in project to provide comprehensive flood protection. Next, for the construction process is material. The material we're using are aluminium metal, for its low cost and lightweight. The rubber gasket is in charge of the river bank wall. The metal cover completely sealed in the basin to protect the debris out. The formwork is compressed in a polyester and is 4 to 4.8 mm thick. The The flood wall is covered in high-impact Kevlar to reduce damage from flotsam hits. With laminate strip and a polyurethane foam core, the flood wall is sturdy and impact resistant. Is the method. First, we drive a top and spring loader up a log may suspend the flood wall in the elevated portion in the power system plate. And interval motorized separators drain pipe run down the foundation bottom to discharge any leaks. Zero leakage on the dry side since the pump appears quicker than leaking. The flood will flood and rise at the basin face. As the water exits in the basin, the wall returns to its original location. The barrier leak close to prevent inflow garbage or debris. The high correction lock the barriers until the water subsides. To avoid ponding on the dry side, a drain is reduced side is piped into the foundation and pushed via the spillage. In addition, the system design allows for utility pass-through and the general inflow well height. The last is appearance. The appearance is a system of concrete footwall we underground entrenched concrete channel. A drain pipe system of a 4 may ablate the flood wall appropriate to avoid flooding. The wall will also be lifted, and when the flood water fills the concrete basin, the flood basin are lowered underground after the flood make the system invisible. So the foundation depth are 1.8 times the height, 5.9 foundation for 5 foot base. That's it. Thank you.
Okay, Assalamualaikum. For the next part, which is technology, the technology that have been used is flood walls. A flood wall is a freestanding permanent engineered structure designed to prevent encroachment of floodwaters. Flood walls, which are often made of reinforced concrete or masonry, act as a flood barrier, protect structures from hydrostatic and hydrodynamic loads, and may redirect flood-borne debris and ice away from the structure. Flood walls have normally placed some distance from the building to avoid having to make structural modification to the building. Flood walls are the technology being used in our research to reduce the percentage of flood occurrence. And next, for the next technology is the mapping drone. UAV drones are equipped with different state-of-the-art technology such as infrared cameras, GPS and laser, which is consumer, commercial and military UAV. Drones are controlled by Remote Ground Control System (GSC) and also referred to as a ground cockpit. Mapping known tract of land was once a highly time-consuming effort. Today, high-tech drones for unmanned aerial vehicle (UAV) mapping can significantly reduce the turnaround time for gathering data and representing it with a map, while providing more accurate data than is possible with conventional mapping technology. It is used to map the research area to get the data needed to build the flood walls barrier. Next, for the next technology that can be used is LIDAR. Another technology that is used to prevent floods is a light detection and ranging map, or known as LIDAR. This technology are for monitoring water levels by satellite, laser and underwater, and making flood forecasts by combining data in one location. LIDAR stands for Light Detection and Ranging, a remote sensing method that uses light in the form of a pulse laser to measure range to the Earth. This technology could be utilized to create a higher resolution topographic system with a less than 20 cm error range. Topography is the description of land features such as valleys, mountains, hills and rivers, as well as their depiction on maps. Topographic LIDAR typically use a near-infrared laser to map the land, while bathymetric LIDAR use water-penetrating green light to also measure sea floor and riverbed elevations.
The next one, I will be explaining the conclusion and the recommendation for this project. It can be concluded that the construction of flood wall brings benefit to the environment and the people in that area, whether it is an urban area or rural area. The excessive rainwater that falls into the concrete basin will push the wall using a hydraulic system so that the surrounding area does not experience severe flooding. In addition to that, the flood wall is a mechanism that does not require much maintenance and does not require any energy. The result from the studies is it can be open up opportunities for further development of flood wall system and develop design criteria for the residential area in a red zone where flood always occur. I suggest that the city council and the government can implement the use of flood wall in an area where flood always occur annually, and the government also can add the sirens to the targeted area to give early warning, and this can trigger the residents to take early action. Thank you.
That's all from us. Thank you.